All right. Well, welcome to apply to receive a free magnetometer. So this is a really exciting project called the EZIE Mission, which is a collaboration between Johns Hopkins University Applied Physics Lab and NASA. And through the EZIE-Mag initiative, you can apply to receive a free magnetometer to study space weather and aurora science. And it is the first of its kind where you and your community can directly engage with space weather and aurora research. So they are offering 700 free magnetometers to libraries, classrooms, after-school programs, and other educational groups across the country. And I'm joined here today by Nellie and Jenny from the EZIE-Mag mission to tell you how to apply and how you can get involved with your community. All right, and of course, in true StarNet webinar fashion, we will start with a quick icebreaker, and I invite you to answer in the chat. Which heliophysics feature do you feel like today? So you can answer with the words or just the numbers, and I'll explain a little bit about these features. So the first option is the aurora borealis or australis. That's the northern lights or the southern lights. These are charged particles ejected from the sun that interact with gases in our atmosphere, resulting in beautiful displays of light. And Nellie will talk more about the science behind that. But maybe you're feeling like an aurora today. You're feeling bright, vibrant, colorful. Maybe you're in the mood to dance. Or are you feeling more like an auroral electrojets? These are electrical currents traveling around the Earth's magnetic poles, pushing a roughly 1 million amps of electrical charge around the pole every second. And so they are responsible for some of the largest magnetic disturbances on the ground. So maybe you're feeling electric and energized, influential. You might be ready to kind of mess things up or throw your influence around a little bit. Or are you feeling like solar wind? This is the constant flow of charged particles streaming off of the sun. So maybe you're feeling like going with the flow today. You're a traveler at heart. You are blasting through our solar system as solar wind. Or your last option, are you feeling like a magnetosphere? This is the region around a planet that is dominated by the planet's magnetic field. So other planets in our solar system do have magnetospheres, but Earth has the strongest one of all the rocky planets. And this plays a crucial role in our planet's habitability because it is shielding us from the solar and cosmic particle radiation. That solar wind, this is really protecting us. So maybe you're feeling dynamic, you're interacting with the elements out in our solar system, and you're protective. There's something you're feeling protective about today. So go ahead, answer in the chat. I'll take a look, see how people are feeling. All right, we've got all kinds of options here. Lots of threes, okay. Lots of solar wind. I love that. We have some travelers in our audience. We have some auroral electrojets. You're ready to be influential. Carly, glad to see someone else is feeling like dancing. I've been kind of dancing all morning. Great, awesome. Well, thanks for checking in, folks. And just as a reminder, you can use the chat feature at any time to ask questions. Just make sure you are addressing your chats to everyone and not just the default panelists. Great, and you are always welcome to borrow this this icebreaker. If you do solar science programs in your library, you will be able to access the recording and the slides after the webinar, and I'll be putting those links in the chat, in the link bank. So come back to this in a day or two. I just put it in the chat again. That is where you can find our recording and also the slides for this presentation. Okay, so with that, I am going to stop sharing and turn it over to our main presenters. All right, yeah, take it away, Nellie and Jenny.
Am I in a presenter mode?
Now you are, Nellie.
Yep. Looks good.
Excellent. Well, Claire, thank you so much for the icebreaker and for the introduction. You did a great job connecting what we're talking about today. So I'm Nelly Mosavi Hoyer. I'm a project manager, EZIE project manager from Johns Hopkins University Applied Physics Lab. And I'm here with Jenny. Jenny D, would you like to introduce yourself?
Thanks, Nelly. And hi, I'm Jenny Liebert. I work with Nelly. I am the engagement and public outreach coordinator here at the lab.
Excellent. So the EZIE mission, as Claire mentioned, it's part of the heliophysics. It's a collaboration between Johns Hopkins University Applied Physics and Heliophysics. As you see, these are the missions. In this picture, I'm showing all the missions that currently heliophysics is working on, and it's either on the implementation or formulation stage. There are so many satellites. Why are there so many satellites? Because the study between sun and earth, it's very complex. And heliophysics focuses on studying the sun and the interactions with the earth and solar system. And the sun and solar activity, solar affairs, they affect the space weather. So all of these missions are trying to understand the space weather. And EZIE mission, it's part of that study focus too, that we're trying to understand the interactions between sun and earth and in general the space weather. So this picture is a famous picture of the Apollo 8. This picture was taken from moon that shows the earth. But is this really how we are in the universe? What is protecting us? I just shown in the last picture that the solar flares and the solar interactions on the solar system. So really what we don't see with the naked eyes is this picture. This picture shows the Earth's magnetosphere. This is the Earth's magnetic field that actually shield us. And that's the reason that we're alive and the humans can live on Earth. It's because the Earth's magnetic field and the shield, the magnetosphere. So what is the magnetic field? The magnetic field is just the invisible force that it's created by the molten iron in the Earth's outer core. And it's like a bubble around us. And this, as I mentioned, it protects us. As you see here on the North Pole and South Pole, these magnetic fields are a little bit less. So these high energy particles from the sun that are constantly coming to us, they can sometimes sneak in from the North Pole and South Pole. And that's why we have the aurora in Northern Pole and Southern Pole. So EZIE mission, it's going to study these aurora. It's going to, for 18 months, we are going to orbit on the, sun synchronous and make measurements on these high energy electrojets, which are intense electric currents that flowing inside the magnetosphere on the polar and south pole and north pole and also equators. So really understanding these currents in a way, it's a way of us connecting the Earth to outer space and understanding the aurora more in depth. So EZIE mission, we're planning to launch in spring of 2025. And it's 3 CubeSat, and the CubeSats are there are smaller size of satellites. So we have different kind of satellites. We have large satellites, we have small satellites, but the CubeSats are like, it's about size of a shoebox and not really big. So 3 of them that we've developed, and they have a very advanced instrument inside them that they will make the measurement for us. I won't go through details of how the measurements are made, but please feel free to look at our website if you like to understand. And then the next page, I will go through the website. There is so much information in our website that we try to make it very easy for folks to understand what the mission is, how we are making the measurement, how the satellite works, how the instrument works. But in general, the 3 CubeSats, so the green area, it's the region that we are interested, the aurora region. So at the sun charging, the 3 spacecraft, their solar panels are charging. And when it comes to this area, the science calibration, it needs to make a calibration. So the instrument is ready for measurement. And as it gets ready, it comes to the green side, it makes the measurements. And we have 3 of them because we need the 3 of them to make measurements to understand the timing and spatial relativity of the measurements. So at least 2 spacecraft is needed for our measurements to be made. So here is the website that I mentioned. It's very easy to use and understand the storytelling of the EZIE mission. There are pictures, there are media gallery. You can read more about the team. But what we like to focus is today is the EZIE-Mag. We have a section, EZIE-Mag. You can go to the EZIE-Mag section and read more about how you can become involved. But with that, Jenny is going to walk us through about the EZIE-Mag and how you can be part of our EZIE mission.
Thanks, Nellie. Well, hello, everyone again. Nellie and I were very excited to speak with you all today, so thank you so much for being on this call. So Nellie, if you could just go to that. Thank you so much. So you might be asking after hearing Nellie's presentation, like, what is a magnetometer? Well, a magnetometer is a device that measures the strength, direction, and change in a magnetic field. It also can detect the presence of metallic objects. So this product from our lab measures the magnetic field of Earth, and it can be used with students, your library audience, museums. So my point of saying all that is that not just libraries are going to receive these or can put in a request to receive these, but different kinds of educational institutions around the country can. So when you are using your magnetometer, you'll be using it with a larger group of citizen scientists all around the country. So Nellie, if you can. Thank you so much. So with that said, libraries are definitely very high on our list. And if you are a recipient of a magnetometer, after you use our entry form to provide your information to receive one, we do ask that you use it with your audiences. But other communities that will be getting them, of course, Indigenous communities is high on the list. So if you know of any Indigenous communities you would like to connect Nellie and myself with, we would love to hear from you as well, or hear from you through Claire, because we'd love to get these out to Indigenous communities. Also, if you know of any Title I schools you'd like to send the link on to, please forward that link on to them. Any STEM nonprofits, especially STEM nonprofits that serve young girls, museums and libraries, as we talked about, and also science centers. So of course, once you get that QR code and that link, like I said, we are more than happy for you to pass it on to any colleagues you think would be great to receive one, to use it with their audiences. So next, Nellie. So as I had kind of touched on, it is really, you are a part of a mission. So your data is going to be shared with us here at APL and with NASA. And we have a section on our website where once you get your magnetometer, and I actually have it right here, so you can see mine, you can actually just plug right into your computer and you'll be able, with a USB port, and you'll be able to upload your data to our website, to our Science Gateway. And then your data will be used and seen by us and other scientists, but also will be shared with NASA and will be shared with other institutions around the country. And just to give you some idea of the cool institutions we already have on board using this, the Hayden Planetarium in New York City, for example, has a magnetometer, and they'll be recording their data for us, as well as the Bishop Museum out in Hawaii. So they'll be getting one as well. And some other places like the Kennedy Space Center will be eventually getting one as well when we go down there in December as a team to do a talk down there. And actually, this gentleman that's on this photograph, I should mention as well, Rob Barnes, is a scientist that works with Nellie and me, and he is the one that, is it fair to say, he put together the magnetometers for us, right, Nellie?
That's correct, yes.
All right, so next slide, please, Nellie. So just to really drive it home, we're really trying to engage everybody in this mission. The aurora borealis is definitely something that's so intriguing and so many people hear about. And it's almost like this is myth that people can't, they think they can't get to travel that far away to see it, but there's always a way to be a part of it. And we just really want to increase engagement in this mission. And we really want to share the citizen science message and make sure that libraries and your audiences can be a citizen science with all of us as well. And we want to make sure once you do receive a magnetometer, you really stay engaged with us throughout the process as well.
Excellent. So these are the 650 magnetometers here on the picture, but we also have the picture of some of our interns. So what we are very proud that our interns from different levels, from high school to PhD level, have been part of this mission, and they have helped us to make this 650 available for distribution. Why does it matter to have so many magnetometers? Well, these ground magnetometers, they can help us to measure help with the scientific research, environmental monitoring, magnetic anomaly detection, and also for space weather protection. So we don't have anywhere around the world, 650 magnetometers that are the same. So this unique magnetometers that we are making available to you, so you can be part of this data collections, are going to be very unique data set that they're going to be so much, capabilities with this data that we can measure and monitor. Again, this mission, it's based on volunteers that we like the volunteers to help us on the solar eclipse that this summer, this April, we asked, from volunteer from APL, Applied Physics Lab, if you're going to travel with the solar eclipse, can you take a magnetometer and make measurements? And we had over 30 volunteers that they send us pictures from their magnetometers as they were setting up. So for the first time, NASA has 30 magnetometers around the eclipse totality to make the measurements. And our scientists are analyzing these data. The other, for example, usage of these magnetometers are very science quality data. They can collect very scientific quality data. One scientist in Iceland, he wanted to understand the lava flows and the Earth's magnetic field as the lava flows. So we sent him 5 magnetometers to make measurement, and he's constantly uploading the data for us. So we are understanding the Earth's magnetic field with the lava flow. We had another intern that, for example, he wanted to understand the Earth's magnetic field in the balloon mission. This is part of University of Maryland balloon payload program. And we had the EZIE-Mag for the first time on the balloon, so he could measure the Earth's magnetic field as the balloon altitude was changing. So overall, the engagement with the community, it's very important for us to going to classes. If you have any, as Jenny said, Title I schools or other schools that STEMs that you think that they would benefit from having a magnetometer, we're happy to, either to the Zoom call or different ways to reach out to them and make sure they are part of the EZIE-Mag community. For some reason, I can't click. Oh, this is the EZIE-Mag workshop. We just had our first workshop last June in the Navajo Nation, and they hosted us. We had 3 days of EZIE-Mag workshop, and this was very beneficial. We had audience from around the country that they were listening, and they became aware of how they can be part of the EZIE mission. So our goal is to observe the world, connect the world, collect data, and connect the data, and create a really meaningful experience for our users. So we are very excited that you are part of this webinar. I'm hoping that this is just the beginning of our collaborations. And with that, I will let Jenny to have the closing thoughts.
And once again, yes, we're very excited to have librarians, especially on this mission. I think it's a wonderful resource for us, and it'll be a wonderful relationship. I do want to add as well is when you get your magnetometer kit, once you, of course, have to fill out the form and request one, there will be instructions online for you to follow. We'll eventually have videos for you all to follow, but there is an instructional manual, and there will be a chat bot as well. So you'll have somewhat live assistance online as well if you don't have if you're not feeling the instructions or you have a question about them or there's something that pops up in them that you don't quite understand, there'll be a bot to assist you. And of course, you can always send a note to Claire, and I'm happy to jump in as well. But there will be lots of support online for you all to support your EZIE-Mag. But in closing, we would love for you to stay connected. That QR code on the screen is a part of our, will take you to our newsletter, because this is really an ongoing thing. This mission launches next year, and we'd really like you, as soon as we get the magnetometers out to everyone, we'd really like you to set them up right away, get them going right away, and start uploading data. And we'd really like you to continue doing that and celebrate the launch with us as well, like next year, and just keep having that connection with us here at the lab. So with that said, I just want to, again, thank you all and ask anyone if they have any questions for Nellie or me.
Yeah, we've got some really great questions. So the purpose of this webinar is kind of just to introduce this mission and get you applying, but we can answer some of these questions, and also just wanted to reiterate, tutorial videos are coming soon that will walk you through how to use it. And we can always hold, we were talking earlier about holding another meeting in a month or so after you've received your equipment to do a Q&A and sort of a office hours. But let's get through some of these amazing questions. Someone asked, are there specific times or events during which we should be making and taking measurements?
Oh, that's a great question. That's definitely a Nellie question.
Yeah, so this is a great question. These magnetometers, we like you to collect them constantly. But if you have the magnetometers, there are apps that they talk about the solar activity. So, for example, last weekend, there was a big solar storm. And, I got emails that, oh, I have my magnetometers in the backyard this weekend to make measurements. And they send us some collection of the data that they made. And you could see a huge jump because of the solar flash. So, our goal is for you to constantly make measurements, but there are events that are very cool to make the measurements to see the changes on the magnetic field with the solar storms. That's just one example.
Another question was, is this limited just to USA libraries, or can libraries in Canada also participate?
I would recommend everybody who is interested to join and do the survey. And then based on the location, like the northern part, closer to northern part where the aurora is, it's the attractive area for us. And we like to have more ground magnetometers toward closer to northern pole. So Canada, it's a great candidate. So I would just recommend everybody who's interested to do a survey and show your interest.
And Claire, can I actually add something too, just because I've seen this in other like webinars or Zoom calls I've done. As far as it comes to STEM or STEAM clubs, yes, we would love you to get this out. Like if you're a library and you have a STEAM or a STEM club, please like apply, use that survey link form that Nellie was just mentioning, and please apply. We would love to see this. If you even have a connection to a robotics club at your library, or of a robotics club in your neighborhood or in your community, please pass the link on, because we would love those kind of resources to use the magnetometer.
Yes.
Great. And I'll ask these two questions at once because they're kind of related, but how often would you want people to be collecting the data? And let's see, about like how time consuming would it be in general?
I don't think it's that time consuming. At least once a week, we would like it. So these measurements are constantly made, and we're hoping at least once a week you download the data. So you are collecting the data in the magnetometers, but once a week we would like you to go to the website and actually download it in the EZIE-Mag website. As far as time consuming, we are trying to make it more easier to download. I would say about like 10 to 15 minutes time that it will take to download the data. Great.
And I know you do have an age range in mind, but if you could say like what do you think is the most appropriate age range to be doing programming around this type of stuff?
Well, I'd say if the libraries have a school in mind or have like a STEM club in mind, we definitely would say like junior high to high school would be ideal. But Nellie, I would say, if you can correct me on this, if the library has a younger constituency, I would say still apply for a magnetometer and just make sure that the library staff is using the magnetometer with the students or the audience that's younger when they come in. We definitely want, if it's going to be a more hands-on thing, we want the older students to be using it. But I think for younger children, library staff more than welcome to use it with them, but just make sure it's the staff using it.
Yeah, just for, safety and the APL policy, we were told the 8th grade and higher, but really this is educational for every age, as Jenny said. So if you have students that are younger, as long as there is a staff or teacher that help them, it's, they can see how the data is collected. Every age can see how the data is collected.
Great. Let's see. Vivian. Hi, Vivian. Nice to see you out there. I saw her at ALA. Is wondering if this can be used in conjunction with the NASA Astro Camp curricula.
I'm not familiar with the NASA camp.
That's something I might be able to help with. I am not familiar with it either, but Claire, if you want to connect us, I'm more than happy to look over it and just see if there's ways to connect it. But like I said, I can't say off the top of my head because I'm not familiar with it.
Awesome. Yeah, Vivian, just go ahead and email me the curriculum and we can take a look and see where it would fit in. All right, folks are wondering, for how long should they be collecting the data and submitting it? So will this end at a certain month, in a certain year? What's the duration?
So our duration of the mission is 18 months. So our whole goal is to have these magnetometers, ground magnetometers, working while we are collecting data, because this is really complementary to the data that the scientists are taking. So the scientists are collecting data with these 3 small sats, CubeSats, and these ground magnetometers are going to do the same thing, but from the ground collecting data for us. So our goal is to have that during the lifetime of the collecting of the mission, data collection.
All right. And a couple questions are about location of where they should be placing the magnetometers. Does it need to be placed anywhere specific, indoor, outdoor? Can it be moved around? For example, one person asked if they could take it to schools, a different school every week to collect data at those different locations, or would you prefer it all in one spot?
No, they can be different. So this has a GPS inside of it. So the location of where you are collecting, it's actually going to be part of the data. So we know where is the location of the data it's being collected. Just for cleanliness of the data, if you have it close to a power line or let's say a fridge or a magnet, the data will be contaminated. So for cleanliness of the data, if you're collecting to help us, it's better to have it in outdoors so there is no power line or any contamination. But for classroom purposes, I actually encourage you to take it to the classroom and just show how a magnetic field and magnetometer works. So there is no limit to where you can take it. But for our purposes, if you over the night, like maybe you can take it to the classroom and then overnight put it in the backyard. So it's continuously making the measurements for us.
Great. I really like this question. I had to scroll back up for it. Just, for science curiosity, would different parts of the country get different sets of data?
Yes, they will. So that's why we like to send it around the country, actually around the globe, so we can see a mapping of the magnetic field around the globe. So yes, each part will have its own signature.
Awesome. And then a question about timeline. What is the timeline for the application process and receiving?
That is
Jenny?
a great question. I was actually going to make sure I touched on that before we all signed off today. So fill out the form and we will get in touch with you right away if you're selected, just to confirm your data. And then distribution of the mags will probably start about mid-November, beginning of December.
So our launch, as Jenny said, our launch is spring of 2025. So we want to make sure that you have the magnetometer and you're ready to go as we are getting ready for our mission.
Great. If keeping it in the backyard overnight, are there temperature limitations? And related to that, someone asked, can you leave it outdoors or does it need to be taken indoors at the end of the day?
They can be outdoors, and actually on the videos that we're going to post, there are, what's the best way to store it, like it's in a cooler or, in a wooden box that it's more temperature controlled. So there are instructions in the manual and in the website that how and where to put it for best data collection.
All right. And will the information collected be printable for the children to examine?
Yes, they can print it out. They can go to the website and print it out. So that's a great question. Yes.
Awesome.
I feel like there's some good STEM activities in that too, which I'm happy to talk about at a later time.
Awesome. Yeah, so someone said, oh, good, I was hoping there would be a manual. So yes, on the website, which is in the link bank, there's an area you can go to get more information, and there will be video tutorials coming to the website soon. And if you have questions on where to find those, feel free to email me and I can make sure they're added to the link bank, so just so you can find it easily. And they said, this project is so exciting. Thank you for offering this webinar. I'm very excited about it too. It's just a fun way to kind of tie in what's happening right now with solar maximum and the auroras. And if you're in an area where you haven't been able to see the aurora, this is another way to engage with that and watch the data and watch how it changes as we enter and are experiencing solar maximum. Let's see. Can it be kept indoors overnight if there isn't a secure location outdoors?
Yes, you can, but just make sure, again, the instructions are clear, but make sure it's not next to a magnet, for example. It's somewhere that it's distance away from like your computer, so it's not contaminated with currents and the magnetic field of any devices.
I put the link to the application in the chat again. I'll put the link to the link bank, and just keep coming back to this link bank. I'll be updating it with the recording, with the slides, and when the videos are ready, I'll put the videos there. So that's a good one to just bookmark, to kind of keep coming back to find the links to the application, the webinar recording, and all of that. And you can always email me if you're missing anything. My email is in that link bank, and I'm happy to point you in the direction of the resource you're looking for. So, all right. Can science centers apply as well as libraries?
Definitely. We would love, if you are a science center that is on this call, we would love for you to apply. And also all the librarians on this call, if you know a really great science center you'd love to have one, please forward this information on or put them in contact with us, as we'd love to have science centers do this.
All right. Besides the data, are there any program requirements?
No, there is no program. Everything that you need, it comes to with the magnetometer kit.
Yeah, this is really like an informal education tool, which is one of the reasons why we were saying as well, like if you have a school in mind as well, or students that you work with, we love for it to be recommended to them, because we don't want to have any constraints on it. We want this to be like a really fun science experience, and we want people to enjoy them and have them in their classrooms. So we don't want any of those kind of barriers up.
Mm-hmm. And if anyone is on the call that attended the webinar in September where we built our own homemade magnetometer, just so you know, like that data that it's collecting is not high enough like science quality to be submitted to the citizen science aspect of this, but it's a really, if you're doing that with your patrons or you have one in your library, it could be a really fun way to just compare the data that you're getting from your homemade soda bottle magnetometer with your EZIE-Mag, and really see, how those are different, and talk about why are you getting different data points with those. And is this something that can be circulated with different groups? Phyllis, I'm wondering if you could expand a little more on that. Are you thinking like as a circulated item in your library that people can check out? Okay. Yeah, so often, Nellie and Jenny, the libraries they put STEM tools into kits that people can check out. What is your recommendation for that?
I think as long as they are 8th grade or above and they have some experience on how using that, that we are good, to do that. It's a very unique question. I never had that question, circulating that, but I think as long as it's working and it's operating, it's safe to give it to someone else to use it.
Yeah, I think that's a great idea. Like I come from a museum background. I'm a museum educator by training, and we'd always put like those kind of traveling trunks together, or a box you could borrow. So if there's something that your library can do, I think that's a great idea, and just give them an amount of time they could have it so they can bring it back so someone new can check it out. Same goes for the science center, since that question came up. So if you do know any science centers and they'd like to do that, I'm also happy to talk to them about that kind of process as well, maybe putting it in like a borrowing situation.
Yeah, I would say someone brought up the point of it might be a really expensive piece to be circulating. And I would guess we could not, that the team would not be able to replace it if it got broken. So it's kind of up to your discretion how you would want to check it out. Maybe you check it out to a school teacher and they can do classroom stuff and then return it. So yeah, definitely you would have to kind of think about your community and what would work best if you're going to do a circulating.
Yeah, Claire, that's actually a great caveat. Like I would say maybe not an individual. We would probably want to, if your library is going to lend it out, to go to a classroom or go to a museum or go to someone that's actually going to be able to use it with like a larger audience, especially like an audience of kids or junior high or high school.
All right, and folks are asking about that homemade one. I'm going to put the link to the chat from the link bank from that webinar, where you can access the instructions for making a soda bottle magnetometer, the webinar recording, and the webinar slides there. All right. Trying to see if I missed anything. I think some folks are interested in if the professionals, the SMEs like Nellie, could do any type of outreach. Like, could there be a presentation aspect of this? I answered that, at StarNet, we occasionally do outreach. So email me. We can put together something. And I didn't want to speak for Nellie or Jenny. I know they're very, very busy.
We are very happy to do that. If you have a large audience of students, we would love to talk about our mission, talk about some of the APL NASA missions that we work on, and get them excited.
Awesome. Yeah, if you're interested in that type of stuff, or more professional development, the three of us talked earlier about how we could hold once you receive your magnetometers, we could hold another webinar to do PD for you and your staff to learn how to use it, or even just an office hour if you come with questions. So I will be in touch with the folks who registered for this webinar for future PD around the magnetometers. And Candace, are there any other StarNet webinars coming up? We are in the process of doing a series, keeping with heliophysics. This is the year of heliophysics. Starting in November, we're going to be having some subject matter expert talks for them to tell you about the research they're doing with the sun, give some, resources about activities. So those aren't on our website yet, but if you check back, I'll put the link to the chat to our webinar page. I'm scheduling those literally today. So check out our webinar series here, put the link in the chat. As of now, nothing is up yet. This is our last one. But starting November 19th will be our next webinar, inviting some brilliant heliophysicists to share about the research they're doing. All right, well, I think we are out of time. This was just a 30-minute kind of informational one, but please reach out to me with questions. I'd happy to keep this conversation going with you. A big thank you to Nellie and Jenny for sharing this awesome opportunity with the libraries. And we will be in touch with further things. So get your applications in and email me if you have any questions.
Thank you so much for having us today. It was very great.
Yeah, thank you, Claire. This was wonderful. And thank you everyone for jumping on this Zoom.
Right. Thanks, everyone.
Thank you. Bye.
Bye.
If this is the left